June 6, 1944. Dawn breaks over the Normandy coast. A thick mist clings to the churning sea, where landing craft lumber forward through icy waves. The roar of engines mixes with the distant staccato of artillery, sending shivers across the sand. Soldiers huddle inside Higgins' boats, gripping rifles, hearts hammering, eyes fixed on the grey horizon. From the cliffs above, German machine gunners scan the surf, confident. They believed no army could invade here without ports, no harbour to unload tanks, ammunition, or food. Their defences are formidable: concrete bunkers, minefields, barbed wire, and cannons trained on every beach. They wait, expecting the assault to falter. But across the water, the Allies carry an audacious secret. Floating harbour sections, prefabricated and designed in secrecy, ride with the waves, poised to turn the tide. What the Germans dismiss as impossible is about to unfold. Engineers will build a functioning port overnight, under fire, in the teeth of one of history's largest invasions. The first boats hit sand. The gamble begins by early 1944. The Second World War had reached a pivotal moment. The Allies had secured the skies over Western Europe and slowly pushed Axis forces back in Italy and North Africa. Yet the Western Front remained largely untested. Hitler's armies, entrenched along the French coastline, believed they were safe. They had transformed the beaches into a fortress known as the Atlantic Wall. Thousands of kilometres of reinforced bunkers, artillery emplacements, minefields and anti-tank obstacles stretching from Norway to the Pyrenees. German planners were confident that any invasion would fail without access to deep-water ports. The Allies, they reasoned, would struggle to unload troops, tanks and supplies directly onto the beaches. Logistic planners in Berlin dismissed the threat of a large-scale landing on an undefended coastline. The Germans had fortified key ports such as Cherbourg, Le Havre and Calais, believing that these would be the only viable landing sites. Normandy, with its shallow beaches and lack of infrastructure, was considered unsuitable for a major assault, but behind the Allied lines, a different picture was emerging. Operation Overlord, the code name for the planned invasion of Western Europe, was taking shape under the direction of General Dwight D. Eisenhower, Supreme Commander of the Allied Expeditionary Force. The scale of the operation was unprecedented. Over 150,000 troops, 5,000 ships, and 11,000 aircraft were being mobilized for a single day of landing. Planning had begun in earnest in 1943, combining British and American strategic insight with an unyielding focus on logistics. One of the central challenges became immediately clear. Without ports, the invasion risked stalling within days. Supply lines had to be established across 60 miles of storm-tossed water. Ammunition, fuel, vehicles and food could not be left waiting offshore indefinitely. Allied engineers, military planners and naval experts were forced to confront a staggering logistical problem: how to build a functioning harbour where none existed, and how to do it under enemy fire. In response, British and American engineers conceived a radical solution: Mulberry Harbors, temporary, prefabricated ports designed to be towed across the English Channel and assembled offshore. Each harbour consisted of massive floating roadways, concrete caissons and pierheads designed to absorb the pounding surf and allow rapid unloading of troops and vehicles. The project required secrecy, precision and extraordinary coordination. Tens of thousands of workers across England laboured in relative anonymity, constructing the components in massive shipyards and ports, often under blackout conditions to avoid German reconnaissance. Meanwhile, the Germans remained largely oblivious. Hitler's generals, convinced that only established ports could sustain an invasion, focused their defences on Calais and the Seine estuary. Dummy installations, controlled leaks and double agents fed the illusion that the main assault would target these areas. Normandy's beaches were lightly defended in comparison, but still deadly. Omaha, Utah, Gold, Juno and Sword were all prepared to resist landing attempts, yet German planners assumed any supply operation would fail quickly, rendering the entire beachhead unsustainable. The Allies also relied on a broader deception campaign known as Operation Fortitude. Fake armies, inflatable tanks and falsified radio traffic suggested a landing at Pas de Calais. German reconnaissance observed the build-up along the southern coast of England, convinced an invasion was imminent elsewhere. This combination of strategic deception and innovative engineering created a narrow window of opportunity. The Americans and British understood that success depended on surprise, overwhelming force, and the ability to sustain it without waiting for ports that might take months to capture. By May 1944, the plan was clear. The first waves of soldiers would storm the beaches under bombardment, facing well-armed defenders and lethal terrain. Behind them, the Mulberry Harbors would be towed across the channel, assembled by engineers, and transformed into lifelines. Every detail mattered. Tidal schedules, landing craft capacities, concrete case emplacement, and storm projections had to be calculated with exacting precision. One misstep could strand thousands of men and vehicles in the surf, turning an audacious plan into catastrophe. The Germans, by contrast, underestimated the audacity of the Allies. They could not imagine an army landing on beaches devoid of ports and surviving. In their minds, logistics defined feasibility. The Allies, however, were about to redefine what was possible. They were preparing not just for a landing, but for an engineering feat the likes of which the world had never seen, an artificial harbour built from scratch, under fire and ready for battle within a single night. The morning of June 6 would not only test courage and endurance, it would test human ingenuity on a scale the Germans had never anticipated. And while German guns roared from cliffs and bunkers, Allied engineers readied their tools, their floating roadways, and their concrete caissons, knowing that the fate of the invasion rested on their hands. By late May 1944, the pieces of Operation Overlord were falling into place. Across southern England, engineers and dockworkers laboured in secrecy, assembling the prefabricated components of the Mulberry Harbors. Each harbour would be a floating marvel. Phoenix caissons, massive concrete blocks, designed to form breakwaters, floating roadways called whales, linking the pierheads to the beaches, and pontoon piers sturdy enough to support tanks, artillery and trucks. Every unit was carefully numbered, weighed and tested for stability. Skeptics abounded. Some Allied commanders worried that stormy seas or enemy artillery would destroy the fragile structures before they could be operational. Even among the engineers, doubts lingered. Could a functioning port truly be built overnight on a battlefield still under fire? The answer would depend on coordination, timing and sheer determination. Meanwhile, German intelligence remained largely blind. Their assessments assumed that any invasion attempt would collapse quickly without secure ports. Defensive preparations at Normandy were substantial but incomplete. Artillery and bunkers covered the beaches, but inland reinforcement routes were sparse. Commanders underestimated the speed with which supplies could flow once an artificial harbour was in place. In the days leading to D-Day, Allied leaders orchestrated final rehearsals, inspections and adjustment. Engineers reviewed tidal schedules, current charts and landing angles, ensuring every detail aligned. By June 5, the harbour sections were loaded onto tugs, ready to cross the channel under cover of darkness. The Germans dismissed the possibility. The Allies knew otherwise. What was about to unfold would not only defy expectations, it would change the calculus of the invasion, proving that with ingenuity and audacity, even the impossible could become reality. The human dimension of the Normandy invasion is often overshadowed by machinery and strategy, yet it was at the core of the operation's success. Soldiers in Higgins' boats felt the surf batter their vessels as they approached the beaches. The water was frigid, churning with mines and floating debris. Gunfire tore through the morning air, and the cries of the wounded mingled with the roar of engines. Every man faced the possibility of death in the first moments of landing, yet they pressed forward, driven by discipline, training, and a shared understanding of the stakes. Amid the chaos, soldiers depended on one another, forming small units to breach obstacles, clear mines, and secure beachheads. Every step taken on the sand was a testament to courage in the face of overwhelming odds. Equally remarkable was the engineering feat behind the Mulberry Harbors. US and British engineers had spent months perfecting a plan that, at first glance, seemed impossible. Floating roadways had to support the weight of tanks, artillery, and thousands of troops, while massive concrete caissons, some weighing over 6,000 tons, were towed across the channel and sunk in precise formation to form protective breakwaters. The logistics were staggering. Each harbour required hundreds of separate components, all prefabricated in different shipyards and ports across England. Timing was critical. Any misalignment could render the harbour useless. Engineers worked through the night, often under sporadic German fire, assembling the sections with extraordinary precision. The success of these artificial ports depended on their ability to function immediately upon deployment. Leadership played a decisive role in turning these plans into reality. General Dwight D. Eisenhower's calm yet decisive oversight set the tone for the operation. He understood that success depended not only on the bravery of frontline troops, but also on meticulous planning and coordination behind the scenes. Field commanders, including Major General Percy Hobart and Brigadier Bruce White, supervised the engineering units and landing schedules with unflinching attention to detail. Decisions were made on the fly. When weather threatened to scatter components, tugs were rerouted. When tidal calculations shifted, assembly sequences were adjusted. Commanders maintained constant communication with naval units, artillery and infantry, ensuring that every part of the operation reinforced the others. Their ability to adapt under pressure exemplified the dynamic nature of Allied command during the invasion. This convergence of human bravery, engineering ingenuity, and decisive leadership created an extraordinary synergy. Soldiers relied on engineers to deliver the supply lines that would sustain their advance. Engineers relied on leaders to make rapid, informed decisions, and commanders relied on soldiers to hold the beaches long enough for the harbours to function. In this intricate choreography, every role was vital, and failure in one could have jeopardized the entire operation. The interplay of these angles also underscores the audacity of the plan. Germans had dismissed the possibility of an invasion without ports, yet the Allies combined meticulous planning with daring improvisation to challenge conventional assumptions. By understanding the human stakes, the technical challenges, and the command decisions involved, we begin to grasp the full magnitude of what Mulberry Harbors represented, a fusion of courage, intellect, and innovation that reshaped the rules of amphibious warfare. From the German perspective, the Normandy beaches were considered secure. Engineers used tugs and precise anchors to sink each block in pre-designated lines, forming the breakwaters that would shield the harbour from crashing waves. Any miscalculation could dislodge a caisson or expose the structure to destruction. Yet despite the rough seas and sporadic shelling from German coastal batteries, the operation proceeded with meticulous care. Floating roadways, known as whales, were next. Massive steel pontoons had to be aligned perfectly, connecting the beach to the pierheads. Engineers worked in near silence, coordinating signals by hand and light, aware that a single error could collapse the entire structure. As the tide rose, waves sloshed over the pontoons, threatening to knock them loose. Men waded into freezing water to secure bolts and chains, their faces set with determination, muscles straining against the current. Above, searchlights occasionally swept the horizon, revealing silhouettes of ships and soldiers moving through the mist. The pace was relentless. Every hour counted. If the harbour was not operational by the morning, the beachhead risked being overwhelmed, supplies delayed, and reinforcements stranded. Officers moved along the pontoons, checking alignments, issuing orders, and encouraging men to persevere despite exhaustion. The coordination between naval crews, engineers, and infantry required constant communication. Small boats ferried materials, while cranes lifted massive steel components into place. It was a ballet of precision, executed under conditions most would consider impossible. Meanwhile, German artillery continued to pound the beaches and nearby waters. Shells exploded in the channel, sending columns of spray into the night. Some Phoenix caissons were hit, forcing crews to adjust placement on the fly. Yet the engineers pressed forward. Their efforts were not merely mechanical. They were acts of courage. Each movement required calm under pressure, trust in their calculations, and unwavering focus. The success of thousands of men fighting on the shore depended on the completion of this fragile structure. By the early hours of June 7th, a remarkable sight emerged. The breakwaters were taking shape, providing the first protection against the relentless waves. Whales stretched from beach to pierheads, ready to carry vehicles, artillery, and supplies directly to the front lines. Small landing craft began ferrying equipment across the new roadways, tanks rumbled onto the sand, and ammunition trucks rolled safely ashore. Soldiers on the beaches watched in astonishment as the impossible became reality before their eyes. Commanders moved among the engineers, noting progress and recalibrating plans as needed. Eisenhower's directives had emphasized speed, precision, and adaptability. The successful assembly of the harbour sections was proof that meticulous planning, bold innovation, and human perseverance could overcome even the most daunting obstacles. For the first time, the Allies were not merely surviving on the beaches, they were beginning to control the flow of men, material, and momentum. Even in the darkness, the transformation of the Normandy shoreline was evident. What had been a chaotic expanse of sand and surf became a functioning supply hub, capable of sustaining the invasion. The Germans, watching from fortified positions, could hardly comprehend the audacity of the operation. Their assumptions that ports were essential, that a beachhead without them would fail, were being shattered in real time. By dawn, the first tangible benefits of the harbour were apparent. Engineers and soldiers alike had turned a shoreline into a lifeline. Tanks, artillery, and trucks moved across the Wales, ammunition and food reached the troops, and the foundations for the Allied push inland were laid. The gamble had paid off, yet the operation was far from complete. The weather remained unpredictable, enemy fire continued, and the full harbour system would require additional assembly in the coming days. The days following June 6 tested the Mulberry Harbour like never before. While the initial sections had been successfully assembled under fire, the engineers now faced relentless environmental and enemy challenges. June in the English Channel was unpredictable. Waves surged, tides shifted unexpectedly, and sudden squalls tossed floating pontoons and caissons as if they were toys. Every component had to be reinforced, adjusted, or replaced in real time. A single structural failure could strand thousands of troops and vehicles on the beaches. Engineers laboured from dawn to dusk, wading chest-deep in icy waters to secure anchors and bolts. Wales, the floating roadways creaked and groaned under the weight of tanks and artillery, requiring constant maintenance. The Phoenix caissons, massive concrete blocks forming the protective breakwaters, were repositioned and reinforced to absorb the pounding surf. Naval crews manoeuvred tugs with precision, guiding components into place despite gusting winds and currents. At night, fires from shelling illuminated the water, creating a dangerous tornado of shadow and motion as men balanced on slippery steel pontoons. Enemy action continued unabated. German artillery attempted to disrupt the harbour assembly, and occasional air raids added to the tension. Shells splashed near caissons, sending water surging over the pontoons and dousing crews. Yet despite the danger, the engineers pressed forward, improvising repairs and reinforcing structures on the fly. Their work became a relentless cycle: measure, secure, reinforce, repeat, over and over, until the harbour expanded enough to handle the full scale of incoming troops and material. By June 8, the first tanks and heavy artillery began moving steadily across the completed sections. Supplies of food, ammunition and fuel, which would have otherwise been delayed for days, now flowed directly to the frontline units. The sheer efficiency stunned German observers. Reports reached German command that Allied units were no longer dependent on captured ports, a realization that sowed confusion and panic. Their defensive assumptions that logistics would stall any beachhead were being invalidated. Over the next several days, engineers continued to expand and secure the harbour. Additional Phoenix caissons were sunk, increasing the protection from waves and enemy fire. Floating roadways were extended, linking more landing craft to the shore. Trucks, jeeps and artillery rolled continuously, sustaining the advance inland. Engineers, soldiers and naval crews operated in perfect synchronization, a human chain reinforcing the material chain that held the beachhead together. Each success bolstered morale. Each obstacle overcome proved the audacity of the plan was justified. The harbour faced its ultimate test on June 19, when a violent storm struck the Normandy coast. Waves tore at the breakwaters, floating roadways buckled, and some caissons shifted. Yet the core structure remained intact, a testament to both the original engineering and the rapid adaptive repairs by crews still working tirelessly in the freezing water. While portions of the harbour were damaged, the system remained operational, and supplies continued to reach the front lines. The storm demonstrated not only the resilience of the harbour design, but also the extraordinary endurance of the men who had built it under combat conditions. By late June, the Mulberry Harbour had transformed the dynamics of the Normandy invasion. What had started as a risky, almost impossible endeavour, building a functional port overnight under enemy fire, had become a fully operational logistical lifeline. Tanks, artillery and reinforcements moved with unprecedented speed. Ammunition and fuel arrived continuously, and the Allies had gained a critical foothold that German forces could neither disrupt nor ignore. The success of the harbour turned what could have been a temporary beachhead into a springboard for liberation. The Germans, finally realising the scope of the operation, scrambled to respond. Attempts to shell the harbour and destroy floating roadways were largely ineffective. Commanders confronted the shocking reality. The Allies had not only landed, they had landed sustainably. The artificial harbour had neutralised what the Germans considered a fundamental limitation of amphibious assault. The audacity, planning and execution of the Mulberry Harbour had rewritten the rules of warfare on the beaches of Normandy. By late June 1944, the Mulberry Harbour at Omaha and Gold Beaches had proven its worth beyond all expectations. Within days, the artificial ports were handling a continuous flow of men, tanks, artillery and supplies. And the logistical nightmare that the Germans assumed would cripple the invasion had been transformed into a well-oiled system. Trucks rolled across the floating roadways, ferrying ammunition and fuel to units advancing inland. Tanks disembarked directly onto the beaches, ready to support infantry against entrenched German positions. The speed of resupply allowed Allied forces to maintain relentless pressure. Casualties were replaced quickly, artillery shells replenished and provisions delivered without interruption. Engineers worked around the clock to repair storm damage and extend the harbour's reach. Within 2 weeks, the beaches that had seemed chaotic on D-Day had become a controlled, functioning supply hub, an unprecedented achievement in the history of amphibious warfare. German forces, meanwhile, struggled to comprehend the scale and effectiveness of the operation. Intelligence reports confirmed that Allied troops were moving far faster than anticipated. The German assumption that ports were necessary for a sustained invasion had been catastrophically wrong. Commanders attempted counterattacks, shelling positions and targeting supply lines, but the Allies' ability to quickly reinforce and resupply neutralised most of these efforts. What had begun as a daring gamble by Allied engineers had now become a strategic advantage that German commanders could neither predict nor counter effectively. The psychological impact on German troops was immediate. Soldiers who had expected to halt the invasion within days found themselves facing an increasingly organised, reinforced and supplied enemy. Morale suffered as reports filtered up the chain of command. Tanks, artillery and fresh troops were arriving continuously, undermining the defensive plans laid out months earlier. Even at higher levels, the German High Command struggled to adapt, recognising that Allied innovation had circumvented what they considered an unassailable advantage. The Mulberry Harbour's success also had profound implications for Allied leadership. Eisenhower and his commanders could now plan offensives with confidence that logistical support would not falter. Field commanders could deploy troops, artillery and armour, knowing that resupply lines were secure. The rapid establishment of these artificial ports reduced the vulnerability of the beachhead, allowed for continuous momentum inland, and set the stage for the liberation of France. Historians later quantified the harbour's impact. By the end of June 1944, over 1.5 million men, 300,000 vehicles and 500,000 tons of supplies had crossed the Channel. The Mulberry Harbour had effectively turned a potentially tenuous foothold into a launching point for the Allied advance. Without it, the invasion might have stalled, allowing German forces to regroup, reinforce and mount counterattacks that could have altered the course of the war. By July 1944, the Normandy beachhead had evolved from a tenuous foothold into a fully operational launching ground for the Allied advance across France. The Mulberry Harbours had not only delivered troops and supplies, they had transformed the strategic landscape. For the first time, an invading force had landed and sustained itself without relying on pre-existing ports, a feat once considered impossible by both German planners and some Allied skeptics. The ability to rapidly resupply and reinforce frontline units allowed Allied commanders to press the offensive without pause. Artillery positions were consolidated, infantry units rotated and reinforced, and armour pushed forward to exploit gaps in German lines. A continuous flow of ammunition, fuel, and rations ensured that momentum was maintained, preventing the Germans from regrouping effectively. Supply lines that might have stalled a conventional amphibious assault instead became a backbone of the campaign. German commanders faced a crisis of adaptation. Their defensive assumptions, built around the idea that ports were essential for sustained operations, had been proven wrong. Attempts to shell or disrupt the harbours had limited effect, and German troops found themselves outpaced, outmanoeuvred, and increasingly demoralised. Reports of the harbour's efficiency reached Berlin, where commanders began to realise that the Allies had not only achieved tactical surprise on the beaches, but also redefined logistical warfare itself. The psychological impact on both sides was profound. For Allied soldiers and engineers, witnessing the harbour's operation under combat conditions was a confirmation of months of planning, ingenuity, and risk. Confidence surged as tanks, artillery, and reinforcements moved with unprecedented speed. For the Germans, the sight of continuous Allied supply lines, seemingly immune to counterattack, was disorienting and demoralising. The fallacy of the Atlantic Wall as an insurmountable barrier became clear, forcing a reactive rather than proactive approach to defence. The consequences extended beyond Normandy. The success of the Mulberry Harbors influenced Allied planning for subsequent amphibious operations, highlighting the role of engineering innovation as a force multiplier. The invasion of southern France, Operation Dragoon, benefited from lessons learned in port construction and logistical coordination. More broadly, military strategists recognized that mobility, adaptability, and inventive solutions could overcome even the most formidable natural or man-made obstacles. Historians later reflected on the scale of the achievement. By late July, nearly 2.5 million troops, 500,000 vehicles, and over 600,000 tons of supplies had passed through the Normandy beachhead, much of it facilitated by the artificial harbours. The operation demonstrated that meticulous planning, audacious engineering, and human courage could converge to overcome what was widely thought to be impossible. The Mulberry Harbors became a symbol of Allied ingenuity, a testament to the capacity of humans to reshape the battlefield itself. The Normandy invasion stands as one of the most audacious operations in military history, and at its heart was an idea so bold it seemed impossible: building a fully functional harbour from scratch, overnight, under fire. The Mulberry Harbors were more than steel, concrete, and floating roadways. They were a testament to human ingenuity, courage, and the determination to turn imagination to reality. Across the channel, men waded through icy waters to secure anchors and bolts. Engineers braved artillery fire to assemble colossal caissons, and commanders orchestrated thousands of moving parts with precision. Every tank that rolled ashore, every ton of ammunition that reached the front lines, was proof of the seamless fusion of planning, skill, and audacity. The operation demonstrated that even the most rigid assumptions, in this case the German belief that ports were essential, could be challenged and overcome with creativity and resolve. The harbours also reshaped warfare itself. They proved that logistics could be weaponized, that engineering innovation could rival brute force, and that speed and adaptability could determine the outcome of a campaign. Allied success on the beaches of Normandy was not measured solely in territory gained, but in the unprecedented ability to sustain an invading army in hostile terrain under constant threat. Yet the achievement resonates beyond strategy and tactics. It speaks to the human capacity for problem-solving under pressure, the courage to act when failure seemed likely, and the quiet heroism of those who laboured without fanfare. Soldiers, engineers, and commanders alike contributed to a single extraordinary goal: turning a chaotic shoreline into a lifeline for freedom. As history reflects on that June, it is clear that the Mulberry Harbors were more than an engineering triumph. They were a symbol of possibility. They remind us that in the darkest hours, ingenuity, determination, and collective effort can redefine what is possible, leaving a legacy that echoes far beyond the battlefield. The beaches of Normandy became not only a stage of war, but a monument to human resolve, forever reshaping the way conflicts are fought and won.